Hey, I'm Brad. While the other experimental setups in our lab are good for measuring through-plane thermal diffusivity, we're also interested in measuring in-plane thermal diffusivity of these materials. We're setting up an in-plane thermal diffusivity measurement system that uses an infrared camera for making temperature recordings. The experimental setup is based on the angstrom method, where a sinusoidal heat signal is applied to the sample, and then temperature response is measured at two locations along the sample. By measuring phase shift of temperature response, thermal diffusivity can be extracted. So you can kind of see on this screen right here, we have a heater in the middle of this sample, and then various points are being measured by this infrared camera. And you've got an infrared camera. This is just a function generator that's heating the sample back and forth. So the samples look like this, and there's a heater down the middle of it. That's this really thin wire that we've wrapped back and forth. And then that's heated sinusoidally to allow the heat to transfer from that heater through the material. And then by measuring at a couple specified points from that heater, we can then deduce the thermal conductivity of the material in plane. But that's the sample wired up. So again, through the middle, you can see the heater is that metallic stripe down the middle, and it's just thermal paste. And that's what contains the heater. And then this sample specifically has thermocouples in it, so these other four small wires, those are thermocouples embedded in the sample. This measurement was previously done using those thermocouples, and what we're experimenting with right now is using an infrared camera instead of the thermocouples to get the same measurement. So this is just a 3D printed stage to hold up to 3 different samples in the vacuum chamber at one time with specific reference points so that we can place our points on the thermal camera at exactly where they need to go. So you can see this curve is a little bit behind where this curve is, and that's because the heater's in the middle and point 1 is further away from that. So we're actually just measuring the phase shift between the peaks and the valleys of that sinusoidal wave right there.